This tutorial is for 4th grade, Module 4, Lesson 5. In Lesson 5, we begin our study of angles. We use degrees when we measure angles, and we start the lesson by discussing the fact that a degree is one turn on a circle, and we use protractors to help us measure angles and find their degree measurement. I have two different circle protractor pictures here. We start off with the circle protractor to emphasize the fact that a complete circle is 360 degrees. If we look at the first protractor, it starts with a 0 up at the top, and it counts around the circle clockwise. So you can see the numbers going around the circle. The last number listed is 350, but then that final group of 10 would take us back to 0 for a total of 360 degrees. So each little mark along the circle is 1 degree. On the second protractor, the 0 is off on the right hand side, and if you follow the numbers, it's counting counterclockwise around the circle. But it's still 360 degrees. So it doesn't matter where the 0 starts or which direction it counts, we're still measuring 360 degrees completely around the circle. One of the questions the students have to answer is, how many 45-degree angles does it take to make a full turn around the circle? If I show that on this protractor here, a 45-degree angle would start in the center, have one side running through the 0, and then another side running through the 45-degree mark. So if I connect that, so this angle is 45 degrees. The question was, how many of those angles can we cover when we turn all the way around the 360-degree protractor? So I have one angle there. This angle would also be 45 degrees. So you can see that I have a right angle, and it's been divided into two angles which are 45 degrees. We're going to see that same thing in the next section. If I draw a line at the 135-degree mark, that would be my next 45-degree angle. And then I have another 45-degree angle here. I'm going to continue around the circle. Next, I'm going to draw a line that goes through the 225-degree mark. That's 45 degrees. And this would also be 45 degrees. And finally, I'll draw a line that goes through 315 degrees. Shows that this angle is 45 degrees, and I have one more angle that's 45 degrees. So in all, it would take 8 45-degree turns to go completely around the circle. A similar question is, how many 30-degree turns would it take? And I'll show that on the protractor on the right. So again, we're starting at 0 here. So this would be my first line, and it would run through 30 degrees. So this is a 30-degree angle. Now all I have to do is keep counting by 30 degrees to go all the way around the circle. And you can see that my 30-degree angle is smaller than my 45-degree angle, so it's going to take more 30-degree angles to complete the turn all the way around the circle. So I'm just going to keep tracing these. I'm looking for my multiples of 30 as I do this. So 150, 180. The next multiple of 30 would be 210 and 240, 270, 300, 330. And then one more 30-degree angle at the end here at 360. So now each quarter has 3 angles, 3 30-degree angles. So I have 3, 6, 9, 12 angles that are 30 degrees. or 12 turns of 30 degrees completely around the circle. There are some other important things to know about angles as they relate to the circle. If we just moved 1 degree on our protractor, if we started at 0 and just moved 1 degree, that tiny movement here, we would be moving 1 degree out of the 360 degrees that make up the entire circle. So each angle that we discuss can be talked about how many degrees out of 360 degrees. For example, I mentioned before this right angle. A right angle makes that nice square corner in the middle. It is 90 degrees. If I start at 0 on one side, it comes out at 90 on the other side. So a 90-degree angle can be considered 90 360ths of the entire circle, 90 degrees out of the 360 that make up the circle. And again, a 90-degree angle is called a right angle. Now I'm going to change this angle. For my 90-degree angle, I started at 0 and I went to 90. Well, what happens if we take this side and we open it up wider? Now instead of having a box corner, this arc shows my entire angle. It is opened up much wider than the 90-degree angle. In fact, it's 130 degrees. So it's a 130-degree angle, which means it's taking up 130 degrees out of the 360 that make the entire circle. Any angle that's greater than 90 degrees is called an obtuse angle. So an obtuse angle would be a 91-degree angle, anything greater than 90 degrees, all the way up to 179 degrees before we hit that straight angle. So obtuse angles go from 91 degrees to 179 degrees. Likewise, I could change the angle in a different way. Instead of making it opened up to 90 degrees, I can take this bottom side and close it. So I could make my angle smaller than 90 degrees. This angle is a 60-degree angle. It's smaller than the 90-degree angle. The 60-degree angle is using 60 of the degrees out of the 360 that make the circle. It is called an acute angle. All acute angles are less than 90 degrees. So my acute angles would run anywhere from a tiny angle of 1 degree all the way up to 89 degrees. As long as it's less than 90, it's considered an acute angle. And finally, what if we took this arm and we brought it all the way straight down through the 180-degree mark? That would be an angle that's opened up completely, and it looks like it makes a straight line, and that's why we call it a straight angle. Its measurement is exactly 180 degrees. That means that we've used 180 degrees out of the 360 degrees that make the circle. And you can see 180 is half of 360, and this straight angle takes up half of the circle. So there's some of the important facts that we need to know about degrees and circles and angles for Lesson 5 in Module 4.